Hey guys, welcome to my YouTube channel. So in this lecture, we are going to continue our understanding on the uniform and non-uniformly doped semiconductors. So in this last class, we have covered the uniformly doped n-type and non-uniformly doped n-type. So where we have come up with a formula to find out the internal electric field that is built. So similar to the condition where here the same thing for the non-uniformly doped p-type. So here also two things that based upon the condition we will come up into the existence of dp by dx that will not be equal to 0. So because of that there will be contribution for ip diffusion which will also be not equal to 0, and based on this one there will be some kind of inbuilt electric field will be produced. So because of that there will be I drift will be happening. So this why this is happening, we are last class we discussed detailedly for n-type. So continuing this, I am not explaining everything. So please watch the previous lecture if you guys have doubt. So that will also be not equal to 0, but both will be in the opposite direction. So the I net that we will be getting is will be equal to 0 as the device is in the equilibrium state. So extending the same formula, comparing the J net which is also equal to 0. So we will be coming to the inbuilt electric field built formula that we discussed in last class. So extending the same thing to n-type, from n-type to p-type, we will be getting the same formula Vt, which is the reference is that this will be, there will be negative, here no negative. So because the J diffusion is taken as negative, so here that value will not be repeated. So ln of p of x. So this is the equation that we will be getting finally. So this I think you guys familiar because we already derived this for the n-type. So this is how the internal electric field that will be developed whenever there is an internal whenever there is a holes movement from one direction to another direction because of non-uniformly doped semiconductors. So let's take an example. So here there is a direction of I will mark the values, so don't worry. So here let's consider some kind of graphical values. So this is drift. Okay, so let me give arrow marks. So this is diffusion. So here the diffusion of something like electron, hole, force, anything. So because of that some internal electric field will be building. So this is internal electric field that will be building. So because of internal electric field there will be drift. So this we are taking for p type. So that is the electric field and drift of the things is happening in the same type. So this is for p type. Okay, if it is electron then it will be in opposite direction. So here the net electric field, that is the external, suppose this is completely internal, so this is internal. So if we are supplying something external like E external is happening here, so E external which is happening here, so the total, so here so let's take E internal to be 20, E external to be 10. Okay, so this is some 10 milliamps, this is 10 milliamps. So the equilibrium is 0, that is without external supply the equilibrium is 0. So if we apply the E external which is equal to 10, then the E net that will be equal to 30, right? So E net will be up to 30. So there will be diffusion of holes to this side. So the total that will be 20 milliamps. Let's take an example of drift of holes. So this is for p type, right? So there will be, because of this external, there will be some diffusion in this direction. Because of this electron direction, there will be some diffusion of holes to this direction. So let's take this to be some 10 milliamps. So the net total current will flow in this direction, that will be the I net. So that will be 10 milliamps. Because this 10 milli, 20 milliamps will be cancelled. So comparing the both, we will get this one. So this is how the things will work. So the internal will be completely equal to 0. So because of this external, E external that we are, the 10 is added here. So some E net is 30. Based on that, we will get some diffusion, drift of holes and currents. So because of this E external, there will be some diffusion. For that, we will be getting some current movement. So comparing all things, so we will get some 10 milliamps in this direction of 4. So like this way only the movement of everything will happen in the semiconductor devices. So let's take the final and last thing, that is the uniformly doped p type. So the fourth one from our observation or our understanding of this one is the uniformly doped uniform p-type, uniformly doped p-type. So this we guys already know, so there will be nothing. So dp by dx will also be equal to 0. So because of that, the diffusion will also be equal to 0. So no internal electric field will be there. So the drift will also be equal to 0. So E will also be equal to 0. So because of that, I drift will also be equal to 0. So comparing everything, so we will get a I net that will also be equal to 0. That's it. I hope this is understood for you guys. So from next lecture, let's even get deeper dive into the profiles of doping, and then we get into the Fermi state. So these all are some prerequisites that we need to understand before entering into Fermi state. Because in Fermi level, we will be covering many things like the probability of presence of electron is the Fermi level, right? So carrier concentration, density of states, many things we will be discussing very detailedly. So before that, these are all things that we need to be mastered in. So then that concepts can be easily understood. I hope this lecture is understood for you guys. So if you guys have any doubt, please ping in the comment section. For sure, I will clear those doubts. So I think we are in a same phase that whatever I am communicating that is understood for you guys. So even if you guys have any suggestion to do, I will for sure listen to your words. So please act based on that. Please give your valuable feedbacks. I will communicate and I will do that in accordingly. So like, share and subscribe. Stay tuned for the upcoming series of lectures and videos. Thanks.